During assembly of my brand new SawStop Contractor Saw, I wanted to check the alignment of the blade to the miter slots and adjust things if needed. The manual is absolutely silent on this subject, and you'll find nothing on their website, and I could find no vendor-provided video or one produced by anyone on this subject. If you call the vendor, they'll send you a PDF that tells you how to align the blade to the miter slot. The document says that you shouldn't have to do this. I mean, they do have zillion-dollar machinery and custom tools to assemble these things, so I would hope it wasn't necessary. But just in case the pallet that my saw was on fell off the dock somewhere, or if I bugger the thing up later, I do want to be able to get things back. By the way, their procedure calls for hitting the saw with a hammer, not exactly a delicate precision-seeking maneuver, right? Well, a guy named Mel Nichols took the vendor's process and gave it the needed precision. So I'm going to show you his process. My video provides some extra information and adds a little bit of flash, but Mel did the heavy lifting. My hats are off to our good friend Mel Nichols. Here's what you'll need. First, a miter slot alignment tool. There's lots of them out there, and here's the one I used. Some alignment videos use a square to check the alignment. Go ahead if you wish. Given that a human hair is 3/1000ths of an inch thick, my eyes need all the help they can get if I want the best results. An 18-inch welding clamp. The key part of this clamp, aside from its length, is the shape and size of the stationary end, which is longer and flatter than normal bar clamps. You need that for the clamp to fit into a little tight space later on. A 1/2-inch wrench. The documentation says to use a 12mm wrench, but a 1/2-inch worked better for me. Oh yeah, you'll need a Phillips screwdriver, but do you really need to see that? Nah. First, remove the rear rail, but you don't have to remove the extension wing. In my case, I did all this work before I mounted anything to the base table. The important thing is to be able to get access to the rear trunnion bolts. So, what the heck is a trunnion? Think of it as the frame of the machine's cutting mechanism. All the parts dealing with the blade are affixed to it, and from the factory, we want that frame to be positioned with the blade exactly parallel to the miter slots. Raise the blade to its topmost position and then lower it about 1/4 of an inch. Mark an X very near the outside edge of the blade, but not on a tooth. Place the alignment tool in the left miter slot. Make sure it doesn't wobble in the slot. Mount the cross piece so that the plunger extends a bit past the blade in its resting position. Move the tool in the slot until the plunger touches the blade. Now manipulate the blade and alignment tool until the plunger touches the center of your X. Rotate the dial face so that the needle lines up with 0. Your tool is now calibrated. To determine how much out of alignment your blade is, we'll do the same measurement as before, but this time with the blade rotated almost 180 degrees. So, slide the alignment tool backwards while you rotate the blade backwards at the same time. Stop when you have the X spot on the blade rotated as far backwards as you can while still touching the X mark with the plunger. Record the value shown on the dial's face. If the dial moved counterclockwise, the value is negative. If the dial moved clockwise, the value is positive. I lucked out. The dial moved counterclockwise, but it moved less than 1/1000th of an inch. Allowing for human sloppiness, I can't hope to get this any better. So even though my saw was aligned well, you still want to see how to fix things if you need to, right? I'll show you the procedure, but I didn't do these steps on my saw simply because I couldn't hope to get it any better aligned than it came from the factory. To align the blade, eventually you will move the trunnion's back end either left or right. So first you need to determine what direction it needs to move. Believe me, this is not obvious. If your variance was positive, that is, the pointer moved in a clockwise direction, this means the rear part of the blade is further away from the left miter slot than the front of the blade. That the rear part of the blade needs to move to the left as viewed from the front of the saw in order to get it parallel. But most importantly, the rear part of the blade needs to move to the right as viewed from the back of the saw. This video shows an exaggerated example. The wooden stick represents the blade if your variance was positive. You can see that to get the blade parallel, the back end needs to move to the left as viewed from the front of the saw. But if you view things from the back of the saw, you can see that we will actually move the blade to the right. But if your variance was negative, that is, the pointer moved in a counterclockwise direction, this means the rear part of the blade is closer to the left miter slot than the front. That the rear part of the blade needs to move to the right as viewed from the front of the saw in order to get it parallel. And, you guessed it, the rear part of the blade needs to move to the left as viewed from the back of the saw. This video shows an exaggerated example. The wooden stick represents the blade if your variance was negative. You can see that to get the blade parallel, the back end needs to move to the right as viewed from the front of the saw. But if you view things from the back of the saw, you can see that we will actually move the blade to the left. Up to this point, I've imparted no new information. Other videos will get you to this point. Finally, we're going to use that special technique that our good friend Mel Nichols came up with. Remove the Phillips screw circled here. Loosen the two trunnion bolts only a half turn at most with your wrench. Now, if you were to read the vendor's instructions, you would gently tap or pry the appropriate trunnion bolt to bring things into alignment. This seems a bit crass, don't you think? Well, so did Mel Nichols. So he came up with the steps we'll do next. Here's his way of gently dialing in your adjustment. It's way cool. If the variance was positive, you need to move the trunnion towards the left when viewed from the back of the saw. So position the clamp as shown here. If the variance was negative, you need to move the trunnion towards the right when viewed from the back of the saw. So position the clamp as shown here. Here are some close-up shots of the business ends of the clamp to help you see how to position them. In both cases, the movable end of the clamp is touching the frame of the saw and thus will not move. But the stationary end of the clamp is against the trunnion, whose bolts have been loosened, so the trunnion will move when the clamp is compressed. To actually make the adjustment, gently turn the clamp's handle and watch the alignment tool as it moves to 0. It is possible that the initial calibration has now changed. To make doubly sure, calibrate again, measure your variance, and adjust as necessary. The good thing is, you can swap the clamp around to the other way and move the trunnion just a smidge back the other direction if you need to. One final note, if you are a mere mortal and can't get your alignment dead on, it is safest to end up with a negative variance because then the back of the blade is angled towards the miter slot compared with the front of the blade. In this configuration, the wood between the blade and the fence has less chance of binding as it exits the back of the blade, thus reducing the chance of kickback. Once you're good, remove the clamps and slowly tighten the trunnion bolts. The best approach is to tighten one a little bit and then the other until both are snug. You can undo your work if you tighten the first bolt completely all at once. Put your Phillips screw back in and you're done.